Warning: the test cases used in this video were specifically written for demonstration purposes and do not cover the entire functionality of the program under test. They are mainly intended to showcase the automation of testing and do not carry significant practical value beyond this demonstration. Let's talk about tests. Today's topic covers unit, integration, and e2e tests. Let's look at them from the perspective of test automation and try to understand the differences between them. So, let's dive in by using a simple application as an example. Our test application will be a calculator program written using the ReactJS library. This application has minimal functionality for a calculator, but allows for performing arithmetic operations: addition, subtraction, division, and multiplication. For demonstration purposes, this program will suffice. Before writing tests, it's important to familiarize yourself with the program's internals. The program includes a calculator component. It uses 4 arithmetic functions: add, subtraction, multiply, and divide. These functions are stored in a separate file since they can be used in any component that requires calculations. Additionally, the calculator uses 2 other components. The first is the display component, which is used to display the results of arithmetic operations. The second is the keyboard component, which is used to create the control buttons for the calculator. Let's examine the application's diagram, which provides a more detailed view of the calculator hierarchy. We'll start by reviewing the calculator component. As you can see, it is a child component of the app component. It uses arithmetic functions, the display component, and the keyboard component. If we write tests for the arithmetic functions, which are the simplest components of the program, such tests would be considered unit tests. In short, a unit test is an automated test that verifies the functionality of a single function or method in isolation from the rest of the code. The primary goal of a unit test is to ensure that a specific module or function works correctly and reliably, independently of other parts of the system. According to this definition, testing the arithmetic functions would indeed be classified as unit tests. If we write tests for the calculator component, this type of testing is called integration testing. Since it interacts with the display, keyboard, and arithmetic functions, it indicates that the calculator integrates all the aforementioned components. Brief definition: an integration test in the context of components checks the interaction between several related modules or components of the system to ensure they work correctly together. The goal of such tests is to identify issues that may arise during the integration of components, which might be missed when testing them individually. If the application is tested through a browser from the user's perspective, covering all stages of the user journey, such testing is called end-to-end, E2E. Brief definition: end-to-end testing is a type of testing that verifies the entire system as a whole, including all its components and dependencies, from start to finish. The goal of E2E tests is to ensure that all parts of the system work together in real-world conditions, ensuring the correct functionality from the user's perspective. Let's take a look at how unit tests are structured. We import the arithmetic functions into the test plan. There are 4 in total. Each function has its own set of test cases written. How do they work? In the test function, we pass the arithmetic function being tested with the required arguments for computation, and then we check that the result matches the expected outcome. Following this approach, we write cases for all our arithmetic functions to verify their correctness. Let's run the tests. As you can see, the testing completed instantly, with all tests taking just a few milliseconds. This is an excellent time performance. Now let's look at the results. As you can see, addition, subtraction, multiplication, and division were all successful. No bugs detected. Now, let's take a look at how integration tests are structured. The code here is more complex compared to unit tests. When the render function of the calculator is called, the React library creates a virtual DOM tree for the calculator component. This tree is a structure that describes how the UI should look on the screen. At this stage, React doesn't interact with the actual browser DOM, but works with its virtual copy in memory without involving the real browser window. This is why these tests can be executed outside of a browser, for example in the console or within a CI/CD pipeline. After rendering the virtual tree, the test begins to interact with it. In the following lines, we simulate user actions, such as clicking buttons to perform arithmetic calculations. We then verify the calculation results on the display of our calculator. As you can see, we don't directly interact with the arithmetic functions. The calculator handles this interaction, making it a clear example of component integration. Let's run the tests. All tests passed successfully, but they took longer to execute than the unit tests we ran earlier. In this case, the time is measured in hundreds of milliseconds, which is 100 times slower than in unit tests. Now, it's time to get acquainted with end-to-end E2E testing. The first and most important thing I want to highlight is that we will be performing tests from the user's perspective. Secondly, we may not know the application's architecture or have any idea of how it works internally. And thirdly, it doesn't matter what programming language our developers are using. We will write the tests in the language we are familiar with. In other words, end-to-end tests are programs that test other programs. There are many frameworks on the market for writing end-to-end tests. The top 3 are Playwright, Selenium, and Cypress. In today's example, we will use Selenium as it is the most widely used at the moment. So let's start writing tests. The first step in writing such cases is to study the DOM tree of our application so that we can write methods to interact with it. The second step is to write a class for interacting with the program from the browser's side. This class will be equipped with 2 methods. The first method is called clickButton. It will click the calculator buttons, taking the button's name as a parameter, searching for it in the DOM tree, and then clicking it. The second method is called checkDisplay. It takes the value we expect to see on the calculator display. If the passed value matches the expected value displayed on the calculator, the test passes. If the display value differs, the test fails. Example test. At the beginning of the test, we check its title, which should be calculator. This is the title of our page in the browser. Next, we click the buttons to perform arithmetic operations. When the equals button is pressed, the result of the calculation should appear on the display. Then we call the checkDisplay method, which checks if the number 6 is displayed on the screen. Next, we press reset and check that the display shows 0. This concludes the first test. Let's move on to the second test. The structure of the code is similar, so we won't dwell on what happens there. Let's see what's next. The newly written cases are added to the test plan. And now we will try to run the test plan. To do this, we enter the command to run the tests in the console and observe the execution of the cases. In this case, a full browser was launched and the automation started pressing the buttons. Meanwhile, the checks we set up were performed. So, our cases completed successfully. Both cases passed and took 10 seconds to run, making them the slowest cases compared to the ones we've seen earlier. Let's summarize what we've seen. In end-to-end tests, we thoroughly test the entire system, from launching the browser to performing arithmetic calculations. In other words, we can confidently say that our calculator website is at the correct address, loads properly, and works as expected. With just a couple of tests, we were able to ensure that the application functions correctly at all levels. Such tests can check many aspects of the application's performance, inject code, dispatch events, and much more. However, there are also drawbacks to this type of testing. The first drawback is the time it takes to run the tests. It took 10 seconds to run 2 cases of this type, whereas unit tests took only a few milliseconds, and integration tests took a couple of 100 milliseconds. The second drawback is the complexity of writing and maintaining these cases. A positive result depends on many factors, such as the stability of the internet connection. Such tests require very careful debugging and optimization. It's time to summarize. Unit tests. These tests check individual components or modules of code in isolation to ensure they work correctly. Pros: fast feedback, easy to maintain, easy to identify errors. Cons: do not test integration between components, miss issues at higher levels. Integration tests. Integration tests check how different modules or components work together to ensure they interact correctly with each other. Pros: identifies issues in component interaction, covers more complex usage scenarios. Cons: slower than unit tests, more challenging to set up and maintain. End-to-end tests. End-to-end tests evaluate the entire system from start to finish by simulating various user behaviors and interactions with the application. Pros: covers the complete user flow, identifies issues that may occur in real-world conditions. Cons: slow and resource-intensive, difficult to set up and maintain. Thank you for watching, and I hope this video was helpful to you.